Welcome, everyone, no matter where you're from. It's 7 p.m. Moscow time. It's time to start. Thanks to everyone who is here on time. And as appreciation to you and as a sign of respect, we're going to start on time. It's a rare occasion that I am not presenting, so you don't see my face. Well, you've seen me quite a bit of times before, but quite a few times before. But today it is my pleasure to introduce to you Professor Dmitry Zaytsev, who is an academic supervisor of a master's program, Applied Statistics with Network Analysis. He is a professor at High School of Economics. He is the leading researcher at our laboratory, International Laboratory for Applied Network Research, and he is also a graduate of our master's program. Even though he was already a professor and had quite a few courses and solid education, including a PhD behind his belt, he decided to join our program and learn more about analytics, and perhaps he will share some of his stories with you. So without any further ado, I am turning the floor over to Professor Zaytsev. I will be answering your questions in the chat. And so if you have any questions about the program, about anything else, I will be behind the screen. But I'm turning the floor over to Professor Zaytsev with today's presentation, which I think is actually quite exciting. He will show you one of my favorite programs for data mining, which is fun and easy to use. And hopefully you will agree that this is something that you can use in your everyday life and work. Professor Zaytsev, the floor is yours.
Thank you, Professor Kuskova. And thank you for your introduction. And 2 webinars ago, I have a very detailed introduction of myself and with my way to network analytics and applied statistics. And maybe I will make a brief, maybe it will be interesting for somebody here. But originally I'm from political science. And I have a background in political science, and political science mostly is into further, I think, mostly is qualitative discipline still. During my study as a student, and then when I started teaching public policy, first of all, I realized that there is a lack of quantitative education in political science and in policy sciences, and this lack is especially characterized in a way that students study statistics, but they do it in an old-fashioned, traditional fashion, starting from the average, mean, median, then standard deviation, then some regression maybe, cluster factor analysis, but without application of all this stuff to the real life problems, either academic or business. Maybe because I have some experience in applied sociology working for business, I realized that this is not a good way, and that we need some better education in statistics, in applied statistics, first of all. And I start from myself, and I just after I received, I was already 10 years PhD holder, I decided to go back to school and studied at the master program Applied Statistics with Network Analysis, which we call MASNA. Now I'm an academic supervisor from the 1st of July, I believe, of this program. And this how I developed this identity, being not only political or policy scientist, but policy network scientist and computational political scientist that I'm trying to be. So we have MASNA, Master of Applied Statistics with Network Analysis, our offline program, and the MDNA, that is Master of Data Network Analytics, is an online mirror of this offline programs. So MDNA is online program at the Coursera platform. I already told you, I think one webinar ago, that there are 3 ways in social sciences. And one of this way led me to the study of applied statistics. And this way is a combination of theory-driven and data-driven approach. Yes, so we have theory testers that are those who do empirical research. Usually in political science especially, they use regression without deep understanding of theory that they try to test. And there are plenty of research of such that use this approach, and they are very good in publishing actually, because the academic journals like empirical research. There are other applied and academic research that are theory builders. They try to build theories without the empirical test of these theories. And this kind of researchers, by the way, we can find not only in academia but also in business. When I was working in sociological think tank, I met such kind of people. And for example, it was an interesting story. Then somebody came to us with their as a client. It was one of their football club in Moscow, and they were trying to rebrand themselves, football club, and asked us to make a sociological survey. And one guy said that you do not need sociological survey. I will provide you recommendation from scratch. So don't waste your money. So even in applied research in business analytics, you can find this such theoreticians that can say what the business company have to do without any research. Yeah. So knowing these 2 ways, I want to develop my own way, that is pioneers or explorers that combine both approach, empirical research and well-grounded theoretical research. Actually, this types of research can be combined with the approach to the analysis that is well known, that is theory-driven and data-driven. And usually we are talking about that what is the best, what is the better, to be driven by theory or to be driven by data. What we at our 2 programs propose is problem-driven approach to either business analytic or academic research that combine both approaches. So we argue that to be successful at your studies, at your research, at your recommendations, if you are business analyst or business consultant, you need both. You need good theory, you need good data, and all this stuff, theory and data, have to be projected to the problem that you want to solve. So this is the problem-driven approach. It's a little bit complicated maybe, but I will try to come back to this characteristics or main mission of our 2 programs, to be a problem-driven while I am showing you orange. Yeah. So orange is a software that was developed by the professor and doctor of University of Slovenia, that is Janez Demšar. And he is one of our co-faculty at both of our programs. And he teaches actually this course, data mining. And I will, of course, I will not teach you the whole course today, but I will show just several examples and try to show you how this data mining course with orange is different from the same courses that you can find on other programs. And this difference is that we teach data mining not only through data-driven approach, because data mining usually is taught as data-driven course. So you get some data and try to do something with this data and get some sense from it. I'll try to show you that even this completely data-driven course can be transformed into the problem-driven approach. So even with manipulating with data, you can get some sense out of this data, and to get this sense, you need theory and you need problem. So data mining is a course at our 2 master programs, and we taught it with Orange. Orange is an open source data visualization machine learning data mining toolkit that was developed for explorative data analysis. It's very interactive. And one of the developers of this program or software or toolkit, as they said, is Professor and Dr. Dmitry Zaytsev from University of Slovenia. He's been linked to one of the article that presented, and it is based on Python, yeah, Orange. So here is the doctor and full professor at University of Ljubljana, Dmitry Zaytsev. This is his photo. And he's visiting professor at our master programs. And we hope that also, we're sure that he will also record the course on the MDNA program. And at a master program, when he is presenting this Orange in live, he also comes with the Ida Petner, who is a researcher at the University of Ljubljana, and actually his PhD student. So, and together, of course, in offline format, they are interacting and co-teach together. That is also very fun and interesting. So actually, the Orange is open source, as I said, and you can find a lot of stuff in the internet. So this is the main page, that is orangedatamining.com. And there you can, first of all, of course, you can download Orange. I did it myself 2 years ago to my new computer, by the way, just to test again how easy it was. So it was just spend around 15 minutes. And you do not need to pre-install any Python or anything, because everything is in one package that you have unpacked and install, and then it install everything, Miniconda, Anaconda, and Orange itself. So download it. I just put the link to download file. Also, there are a lot of materials at this resource, at the source, and what is maybe for me is very useful is YouTube tutorials. So actually, Ida there is speaking and provide snapshots from her computer. So it's very useful, very useful. And this is one of the reasons why I do not repeat these tutorials, because everything is online. Not everything, of course. There is no the main actor here, like Professor Dr. Dmitry Zaytsev, but a lot of materials you can find at this link. That is why I will show you only some problems that you can solve in Orange, and trying to show how this data completely, it seems completely data-driven problems are tackling at our master programs. I will talk today about two widgets, actually. They called it widgets: hierarchical clustering and PCA, principal component analysis. This is also methods, as you know, of applied statistics. And here you see that before I will show it to you, I have some problems here in data to show, to demonstrate. Yeah. So as I said, I prefer actually start my data mining endeavor with theory. But this is up to you. It's your preferences. You can start from data, or you can start directly from problem. But what is important that here you cannot avoid one of these parts if you want to be a good analyst. So you need all three components to be successful, even if you are a business analyst. By theory, by the way, I mean not some complicated philosophy of the question, but the a sort of explanation, a priori explanation of the social or business phenomena, understudy or explanation of the problem with which some corporation is faced with. I have two examples to demonstrate. Actually, they all came from the real research that we are conducting at our laboratory, and our two master programs. We are led by the International Laboratory for Applied Network Research, and we have the academic research. And one of this research was about the political change and the how do mass protests and protesters actually can influence on political change. The problem here was, if we have a lot of different, and the story is that the protests that we have studied, actually this is a whole movement that was in the majority of countries, more than 80 countries actually, starting from 2008 and 2011. If you remember, it's Wall Street protests, it's Occupy movement, start from Spain and cover all over the world. Here was the problem that we want to understand: how many models or how many types of countries we can find where the protesters try to influence political change. We were trying to theoretically, before experiment, before analysis, based only on theory, hypothesize that there are as much models of protesters' participation in political change as the types of political regime. But here is their trap, because there are a lot of theories of political regime. There are a lot of classification of political regime. You can find very easy classifications that for example, we have three kind of regimes, that is authoritarianism, democracy, and totalitarianism. Or we can find much more detailed typology that's different political regimes. For example, they can even find 50 different kinds of authoritarianism. Even there is a joke for so-called authoritarian regimes that if you remember, there was a film, 50 Colors of Gray. Yeah, so there is a joke in political science that we have 50 colors of authoritarianism as well. So theory cannot help us. Yeah, so then maybe data can help us. So, and I will show you the example of dataset that is called quality of government dataset. This dataset is very huge. It's around more than 2,000 variables for all countries, and it's also different time from, I don't know, from beginning of 20th century to nowadays. So it's a really huge data set. And the problem, and data itself actually without theory cannot also answer this question. I will show you. And the problem here is case selection. So, and this is maybe very usual problem that we can face when we do either academic or applied research. So what kind of cases to select? Maybe even for further qualitative in-depth analysis or another quantitative in-depth analysis. The same we can face with, if we will just not talking only about countries, we can talk about corporations, or like we told about on previous seminar, we were talking, as if you remember, about effectiveness. We were talking about different brands, car brands that compete with each other. So the same question can be addressed here. So if we are working in one corporation, let's say in Nissan, for example, yeah. So who are other direct competitors with whom we can compare ourselves? For example, our sales and the spendings for advertising, with whom we are most similar, and with whom we are more dissimilar. So this is important to know also, because we need to compare our company with other companies, and it's better to compare ourselves with those who are close to us according to the different characteristics. So this case selection problem is the problem for both of both importance for academic research and business analytics. So, and this problem, again, to tackle this problem, we need both theoretical understanding or some a priori understanding. We need data, and we need to combine them somehow to answer this question. How many models in our case with political regime do we have? Are there 3 models or 50 models? Also there is a question about other data. Do we need it? So, case selection with hierarchical clustering. Also a little bit theory here that while we select cases, usually we faced with the so-called most similar cases research design. Why do we need similarities in this case? We need similarities, and we need to compare ourselves. For example, let's say we are trying to, we are automobile industry company, and we try to increase our sales. So let's look on, into our competitors. So, and who are our competitors with whom we have to compare? So we need to compare with a similar company. Why we need it? And this most similar cases motivation show us why we need it. We need it, for example, if we have 2 similar brands, and these 2 similar brands have different effects, what are the different causes of these different effects? So, for example, we have 2 very simple car brands, and one car brand have very high sales, and the other have a very low sales. They are similar according to the in other variables. What different reasons, then what are the different causes that lead to the different effects then? So you see that we need to compare cases, understand what kind of cases are similar with our case and what cases are different with our case. So here is coming back to the protests. Here is actually, this is the most important link. If you want to have some more details about the example that I will show you later, so you can look into this book and read this chapter actually, and see how we trying to solve this problem with hierarchical clustering of countries actually, according to the different models of protesters there impact political change. And as I said before, we have theoretical assumption. We have theoretical assumption about several countries that we think, yeah, that they have to be similar according to their reaction to the mass protests. And according to the changes that follow after these protests. Yeah, we assume, yeah, that the US, France, and Iceland, for example, have to be there. Actually, UK maybe too. That Russia, Turkey, and China have to be together. Spain, Brazil, India, Tunisia, Morocco, Egypt. So we assume that we will find some these 4 clusters at least, and we have some countries under question. Yeah? So you see that we start with theory, and then let's go to the orange and try to solve this problem not from theoretical part, but maybe from data part, and we'll see what will happen. So I will open orange. I already opened orange actually. Okay, so let me delete this. It will be from scratch. So this is how it looks like. Yeah. You first of all you have to download your data. So you take the file widget here, and you see that orange is working with this kind of widget. So orange is like the fruit, yeah. So and the widgets is in the form of these oranges, yeah, that you are connected together. So let's have a look. And this is called, usually they called these widgets very intuitively. So if it is file, you can easily understand that you have to download your data here. So this is how it's look like. You can download it with file or with your link to the internet. Actually, I already download this quality of governance dataset. It's very easy to do. So you just have to, if you're interested in particular in this data, you can just Google it. And this is the University of Gothenburg data set, and you can easily download it. I download basic data set. Here you have cross-sectional time series data sets, and you can download CSV. CSV is the universal language that is better read by the different programs, including R, and Orange is in the line. You can download in other formats, but I just prefer CSV files. I download it on my computer, and then I just find the way to this data set, and it's automatically give me the information about this data set. So the numbers of variables, the name of the variable, the type of the variable, that is very important, numerical, categorical, and the actually this is the machine learning stuff that we have: features, targets, features, access, targets is wise, we can say, and metadata. Automatically he recognize it, he or she or it. Yeah. So then first thing to do is to look into your data. It's very easy to do in Orange. You have to just call data table. You see, 2 oranges connected with the line. Yeah. And it's called that your data is going to this widget. So you can easily double click on the data table, and it will show you your data set. You see?
Dmitry Gennadievich, I'm sorry to interrupt, but in this file widget, you have either accidentally or on purpose set one variable to skip. So yeah,
it's okay.
Okay.
So you have the countries here. You have codes and data. Yeah. And you see that this is a very huge. You mean this? It doesn't matter because I'm showing just the to show you the program. So I will not use it in the article. So you see that there are a lot of variables, and actually it shows you the major information here, so that you have 194 instances. So it's a little bit machine learning language, that the main language. We call it objects, it call it instances, features or variables, we call it variables, more than 300 variables, and so on. Actually, I have to speed up because I'm okay. So to build hierarchical clustering, it's very easy to do. According to the theory of statistics, you know that before you will build the hierarchical clustering or another cluster analysis, you need to calculate distances between variables, yeah, or provide a distance matrix. So here it's very easy to do. You just make distances. See how fast it is. Produced, you always have to watch that you download here the data, because here there is no other options, but it can be. And then you just choose the widget hierarchical clustering. And here is it. Double click. And you know, I hope from theory, that the hierarchical clustering is represented with the dendrogram that show you their most similar cases. And usually this stuff usually goes without it, without this borderline. Usually it is used like a big tree or dendrogram, yeah. And you have manually to look at it and decide what countries is, or what objects goes together, what is the most similar object, what is the less similar object, and so on. Here also you can choose the linkage. Usually we choose var CC name. Here I choose so to see the name of the countries, and so on. But the beauty of Orange here is that you do not need to look at this dendrogram manually or with some pencil, for example. You have this wonderful thing, yeah, like this. And you can actually, in the interactive mode, by moving this stuff, see what are the clusters exist in your data. According to theory, we know that you have to stop. First of all, you have to have diverse clusters, and also you have to stop to cut this tree or dendrogram where this line is not maybe the highest, but higher than according to the previous one. Yeah. So, for example, I can stop here if I need, and I will see 1, 2, 3, 4, 9 clusters. What is interesting here is, and we do not use any theory. Yeah, here we just are completely data-driven. And what is interesting, we have this cluster that is 9th cluster, that United States, Russia, India, and China come together. Yeah. For political scientists, actually, it will be very strange. I hope you understand why. Because United States is democracy. I know that Americans like to argue that they are not democratic, especially it came from the democratic camp. But believe me, it's much more democratic than Russia, for example. And here we have also India, that is also Indians, by the way, they always argue that their country is democratic. Yeah. There are some doubts from non-Indian population, but still. And there is China, for example. So very different countries, according to the political regime, came together here. So actually, I'm not very satisfied with this clustering. even if you will move it further, still Russia and United States, for example, will be together. And we know, and different indices of democracy showed us that United States is democracy, Russia is autocracy. So they cannot be together. And they cannot be together according to the response to protests. Yeah, if you remember here, our original idea. Yeah, so we are not satisfied with this clustering. So if so, we have to come back from the data to our theory and try to do something with data again. Yeah. So if theory said that we have to, for example, project our analysis or start our analysis from the political indicators, first of all, maybe then we have to select political indicators and then do our cluster analysis again and try to understand, do we have proper clustering or not? And if you also remember that, for example, US have to be together with UK, yeah, and Russia have to be together with Turkey. And they, for sure, the Russia and the United States have not be together. Yeah. So let's, we already done this thing. This is what I forgot to say, that you also can here choose columns. So then it will make a clustering of not countries, but variables, yeah, by columns. Yeah. And also here, if you remember, and if you're a fan of the math theory, you can choose different distance metrics. Usually we use Euclidean, but here is a great range of other distance metrics also available in orange. So, okay, we have to select, and it's also select our data according to the theory. And so it's very easy to do in orange. So you just call another widget that is select columns, and let's select columns. Again, if you are only data driven, you cannot select them because you have to understand what all this stuff is meaning. Yeah, what is BTI AAR actually? What you have to do, you have to go to the code book and read it and understand what is hiding beyond this names of these variables actually. Yeah. I know something about this data set, so I want to select only indicators that is about political regime, actually, only. So how to do it? So I just choose the variables that I do not need it, and I will put them into the ignored part of this table. So actually, what do I need? I need VDM indicators. Van index is Van Helsing. I forget the name. Okay, so very famous index of democracy actually. VDM is also, it's not Van Helsing. So I choose only this that I know, for example, yeah, and live with it. Then I can look into the data. What is beauty of this orange again, that you always can look into your data without any further problems with coding that you have in R, for example, in displaying all this stuff in R Studio that is always hanging and so on. Orange doesn't hang. If it will hang altogether. Yeah, so this is our data table, and if you are familiar with data mining, you also can or know something or experience in working with data, you can also see that there are some missing data here. Yeah? Questions here. So, and we know from applied statistics theory that there are different imputation methods of the missing data. And we teach at our master programs about Professor Kuskov, for example, have an excellent lectures about the imputation that we can use. In Orange, it is made wonderfully again, and it is another widget that called impute. Here you can see that he proposed me selected data. I want the same data. I do not want selected data. So, and here you have different options. Cannot make it bigger, but I think you can. Your screens from don't impute, impute with average, and other stuff, and other options. I can, for example, remove instances with unknown data, that we usually do at the first step, yeah, with R or with other programming here. So you see, it's easy, just very fast. You can again look into your data and be sure that it's indeed was imputed. And I have 172 instances, so with no missing data. So actually, there are just very few countries that was dropped. So I'm quite satisfied with this. Here. And then I can go again to the distances. So not forget to make a distances before I select something. And then again, make the hierarchical clustering here. And can again look into my picture. So I can move it, yeah, as I like it, and have a look. Where is my countries? For example, now I have quite a better cluster of countries. That is the first one, where United States, for example, United Kingdom become in the same camp with other European countries. So it's become more actually, it's much more better according to the political science theory than it was before. Yeah? So, Russia have to be with Turkey. I do not see now, but we have to, at least this camp seems as an authoritarian countries. Here is the Russia, here is the Turkey. So they are together. So this is more associated with the initial model. Like here we have US with France, Iceland with European countries, Russia, Turkey, and China together as authoritarian. So now it's become much more better. You see that the only combination of theory with data and data mining can give you some sense, and it's also important only if you have problem here. That's just case selection, for example, in our case. Yeah? So other widgets, also what we are usually want to see in R, for example, like the distance matrix is also available here. It's very fast to calculate. You can just turn it into the countries and it show you the distances here. So it's quite available. Okay, I have 15 minutes. I can also show you another thing. And another problem for last problem for today. It's the dimensionality reduction with principal component analysis. And again, I can just easily show you only the widgets, but our approach is problem driven. So why do we need the principal component analysis and why do we need it? So usually we use it for, according to the title for the reduction of dimensions. And in our example with protests and political change, the problem here is the following, that if we want to study political change, for example, we have to take into account a lot of variables. A lot of how many? It's dozens or maybe even hundreds of variables that we have taken into account, because political change themselves can be measured in dozens of variables. We have actually we have more than 10, I think, very different indices of democracy, popular indices of democracy, that use each of it use about 100 of variables. Also, there are different explanatory variables that can want to explain and try to explain the democratization or the rise of autocracy, including economic factors, cultural factors, social factors, and so on. Yeah. So a very complex variables influence on a very complex phenomena. So we need a lot of data, dozens or even hundreds of variables to analyze. The same problem can be in the business analytics. When we present you, or will present you, I don't remember, the case of the forecast of automobile industry, we made it using more than 100 variables. So again, we have a lot of variables to deal with. One of the decision to this problem is to reduce dimensionality. Means that you can, without losing your variables, you can reduce your dozens and hundreds of variables to several, and then put them into some more simple model like linear regression. With linear regression, it's also important because if you put a lot of variables in the linear regression, even dozens, you will face with several problems. One of this problem is multicollinearity, which means that these variables will correlate with each other and show you a high R square that is not true actually. In our project, there was the same problem, that we need to understand how many factors are important and how to shrink dozens and hundreds of variables into the several factors. And what other data do we need? So if we miss something. So I will show you the PCA using the same quality of government dataset. So let's just maybe remove this. And okay, so I can made it using the same dataset. Actually, it doesn't matter if you will make it from a file directly or from the data table. And again, the widget is very simple. It's called PCA. Yeah. So okay, maybe. So what it showed to me, actually, this is the screen diagram that what do principal component analysis actually do? Principal component analysis take your hundreds of variables and trying to find several components, it's called components, that can explain your variables, your hundreds of variables in a few components. Actually, when Professor Demshar explaining this PCA, he make it in a wonderful, using wonderful style, and of course it's better to see it. Yeah, so I just recommend you to apply to our master program at least for this, and to see how he explained it. I will try to share one of his explanation that I used usually. He said that imagine that you are in the room, and in this room there are a lot of flies, yeah? And then you make a photo shot of this room with the flies and make them static. And what is your, and flies, you can imagine now that flies is your object of your analysis. In our case, it's countries. Yeah. So, and what do PCA is doing? PCA is trying to draw a line on actual dimension, but we can say line for all this room in a way that the distance from each fly will be minimal. Yeah. And it will be your first component. The second component is usually going orthogonal to the first one, also trying to minimize the variance. So, and this is the screw diagram of the PCA that is actually very interesting. In this line, first of all, actually show you the percent of explained variance. So you can see that the first component explained 21% of the explained variance. Two components explain 28, and so on. There are several rules how you have to cut here and how many components you have to choose for your further analysis. One of these rules is you have to take as much component that together will explain no less than 80%. You see that here, even 20% explain on only 64 components. Actually, it's not very good model, and we know it from the cluster analysis that is not very good because the data is very diverse. Yeah, that the India, for example, you remember Russia and the United States become in one cluster. Actually, it can be explained because the greater weights in this data set is for the variables that are about the population, area, and other stuff that the bigger nations become together. Yeah. So it's not actually what we are looking for. Yeah. So, and what we can do, we can add here the theory, yeah, and try to understand if PCA provide us the orthogonal dimensions where our objects can be situated, what kind of data we have to put into this widget. We have to put widgets, such data that will show us, provide us diverse picture. Yeah. So where that can differentiate the countries in 2 dimensions. For example, if you will choose 2 components. For example, let's say that, again, we can select columns. We live with our democracy, and we assume that this can be the first dimension that can separate countries. What can be the second dimensions? Again, we have to study your data and know your data, what kind of indicators you have. Actually, it's very good also to understand what kind of scale here. But I know a little bit the stuff, and I will, for example, want to choose some ecological indicators. You see also how it is. You can just type it and choose it. Hmm. Okay. So I assume that the in 2 dimensions that can separate our countries, I can separate them better if I will take, for example, political regime and environmental protection, for example. Yeah? And can we do it? First, that I see that I can stop with the 2 components because they give me 74% of the extent variance. And next is 3 with 81%, that is more than 80. And also what is the beauty of this orange is that you can, first you can interpret the results. Usually in R, you have to program a lot to get this picture, to get this table. Here it is provided. Here is the loadings of your variables on the factors and eigenvalues, actually. And the theory told us that, I mean, statistical, that your loadings have to be around 0.4. Yeah, so to make some conclusions, here is no 0.4, but at least we have some point more than 0.3, and we can say that these democracy indicators are okay with the component number 1. So the component number 1, then we conclude that it is about democracy and autocracy. And also here we have principal component 2, that is with the higher loadings on the environmental variables, and even 0.5 in these 2 cases with CO2 and fossil. So we can conclude that the component 2 is about environment. So this is what we want to find, actually, according to the theory. Yeah? We can argue that this is not enough, actually, from the mathematical perspective, but for our educational task, it's okay. Also, what is great, and you can find in the orange, that you can also very easily compute the transform data. So this is what I told you, that how many indicators do we have from the beginning? Not from the beginning, but after the selection. We have 14 features, 14 indicators of variables, and we end up with the 2 components. So we reduce our variables from 14 to 2 components, and for each country we get a new value. If you remember the interpretation, PC1 or first component is about democracy, autocracy dimension, and indeed we can see that Eritrea, Yemen, Korea, North Korea, Syria, with -5, -4 on this dimension, autocracy, democracy, it seems true. Yeah, that this is least democratic countries as or authoritarian countries here, and the most democratic have to be in the end. Yeah, so like Denmark, Sweden, Norway, again, it's okay. We know from theory that the Sweden democracy is the best democracy that we can observe for now. And second component is about environment, and that's also actually also seems that we have some sense here. And here is a little bit more tricky, but question, but still we have these values, and we shrink our data from 14 by features of variables to 2 variables. And now, for example, we can take this data and use it in some another modeling, like linear models. And also it's very great. Why? Because we know that one of the assumptions of the linear model is that your access have to be independent, IID. And components are orthogonal. It means that they are independent by a priori, by definition. And this orange package actually is the easiest have the easiest interface to provide you these numbers. Yeah. With SAS or with R, you have to dig it a little bit with coding to have this table. Actually, this is it what I want to show you for today, and I hope that you in love with Orange as I am. And again, you can get at our data mining course at our two programs in online format or offline format with Orange from the Orange creator, Professor Dr. Yanis Demshar. And also, if you will look into these resources, it will help you to prepare for this course. This is it. Thank you very much.
Yes, Professor Zaytsev, thank you very much. There was a question earlier when you were separating the countries. The question was, could you use the population, the number of people who live in the country, as one of the distinguishing or discriminating variables?
Yes, I can use it. And actually, one of my hypotheses why in the beginning, when I just blindly take the data without theory, why India, China, Russia, and United States come together, it's because of the, first of all, that these countries have a lot of people, population, and they have just major area. But the point is that I can get any data that I want. Yeah, but the point is that your choose of your selection of your data selection have to come from theory. And for my purposes, when I was studying protests and how do protests influence political change, so I was in the political science domain, the better indicators to get my clusters was political regime actually, and the level of democracy. And yeah, also I want also to add that if usually, and this is my experience, there's such indicators and variables as population and GDP, for example, also are the most useful variable, useless variables in comparative research, because they are not explained a lot in comparative politics, at least.
Okay, thank you very much. That was an excellent answer. We didn't have any other content and everything else. So thank you very much, Professor Zaytsev, and thank you for everyone who attended our webinar. It was delightful to have you, and thank you for sharing some of the thoughts with us. Not everybody was able to see some of the thoughts you shared, but we appreciate your involvement and we appreciate you being here with us today. We know you have a choice of places to go and webinars to see. This recording will be available on our YouTube channel, and also we'll send you the link to all of our participants. Please join us next week. We're going to be talking about, well, actually quite a few different topics. So Anna has left their next webinar that we're going to have the link to next webinar. It's a little bit up. So I will talk to you about an exciting topic of network analysis and time-driven network analysis, which is analyzing networks and changes in them over time. So hopefully you will join us in a week. Thanks everyone, and please contact with any questions you may have. It was delightful to have you with us. Goodbye.
Bye bye.
Yes, thank you very much. Have a good day. Good luck.
Bye.